Please be sure to like and subscribe. Today we're going to utilize an oscilloscope to diagnose issues on a fire alarm signaling line circuit that you may not be able to diagnose with a multimeter. We'll show you what a normal waveform looks like, along with distortions of those waves based on what sort of interference may be occurring on the system. We will look at the wiring requirements of the Gamewell-FCI fire alarm signaling line circuits. Although robust, there are some conditions that can affect its reliable operation, such as excessive line resistance, wire capacitance, and noise interference. Section 2 of the wiring manual covers the basic limitations. You'll see that the maximum field resistance of the wiring is 40 ohms per circuit, and the maximum capacitance is 0.5 microfarads. The manufacturer recommends the use of twisted, unshielded pair, and shielded wire is not recommended. If you must use shielded wire, such as in a retrofit application, even though it's not recommended, you must use a floating shield configuration. You will need to cut the shield even with the jacket and tape it as shown in this figure. This is showing that we've extended our SLC leads in the panel and connected it to our oscilloscope probe. This is the oscilloscope we use to troubleshoot things. We can't get a lock on the waveform because of varying frequencies, but the nice thing is this red stop button freezes it for you, and then you can adjust it to check the waveform. The smaller waves bottom out at 5 volts, and the taller waves line up all with 0 volts after making adjustments to compensate for the offset. Here's a screenshot of the scope so you can see more detail. Note that the position is minus 11 volts, so it centers on the screen. You need to account for that when you're measuring the height of the waveforms. The smaller waves are about 24 volts peak to peak, and the taller waveforms are about 27 volts peak to peak. This is magnified horizontally so that you can see it's a pretty clean square waveform. When you align the bottom of the shorter waveforms, you see that they offset at 5 volts. And the troughs of the taller waveforms line up with the 0 volt line. If you remember, the maximum capacitance on an SLC should be limited to 0.5 microfarads. Let's see what happens when we introduce 4.7 microfarads, which is nearly 10 times that amount. As you can see, the devices have lost communication. So what we'll need to do is take a look at the waveform and see what happened with the system. You can see that the capacitance has changed the square wave into almost a sawtooth, at least on the top part. And the vertical lines are slanted now instead of being vertical. It also lowered the amplitude a little bit. Now let's see what happens if we put 10 microfarads of capacitance onto the circuit. With that much capacitance, the top of the waveform has really come to a point now, and the slope has increased. It appears that the upper waves have been reduced to about 16 volts and the lower waves to about 20 volts. This screenshot is just to give you a better look of what to look for when capacitance is the issue. The other parameter in the wiring guide was wire resistance. So what we've done is added about 1,000 feet of wire to the SLC circuit with a couple rolls on the floor. Let's see what effect that has on the system. Even though the amount of wire isn't excessive, it's worst case scenario because it's still on the rolls. You see how it sloped the bottom and now there's a little protrusion? We added some resistors in series with the circuit, so now the total resistance is about 140 ohms. And you can see now how it's distorting the waveform, making it more pronounced. And this is a screenshot from the scope, just showing better how it looks. Another issue that can occur is noise caused by LED lighting, which we are unable to duplicate in-house. If you have a fire alarm system that's worked fine for years, and then suddenly you have SLC communication issues, that's an area to investigate. To solve that, you'll need to use noise cancellation modules to filter the noise, and you may need to put one at the fire alarm panel and at each riser box for each floor.